In this short video, we are going to look at unit vectors and what a unit vector is. So unit vectors essentially are vectors that have a magnitude of 1. So we have a formula that we have to use. So if v is a vector and v can't equal 0, we have a formula. The formula says v over the magnitude of v can be written in the component form v1 over the magnitude of v, v2 over the magnitude of v. Now when we're talking about unit vectors, we are talking about vectors that are parallel to the x or y axis. Okay, using those can be pretty helpful. So the first one, you can see we have this horizontal vector. It's a line on the x-axis. It goes a distance of 1, and we call that I. So it would have the component value of 1 and 0. My vertical vector, or this pink vector here, again has a distance or magnitude of 1, and we call it j. So its component value is 0, 1. Now, we use I and j when we write linear combinations. So those ideas help us to be able to express the vector we have as a linear combination. So for example, if we are given that v is equal to the component form v1, v2, then your linear combination would be in the form v1i plus v2j. Now what's important to note here is that I and j act like variables. So kind of like back in linear algebra, we might say 3x plus 4y, where x and y were our variables. I and j kind of have that same idea, where they get attached along to the component values, but we don't actually plug values into them necessarily, or at least not as of yet. And so what I want to look at just real quick is an example. Is an example here that we're given a vector and we have to find a unit vector that has the same direction as the given vector. And then we need to find the linear combination that is equivalent to the given vector. So the first thing that we have to do is we need to remember, or we need to recall, that your unit vector uses the formula v over the magnitude of v. Okay? And so with that, the first thing that we need to do before finding our unit vector is we need to find your magnitude, which again we call double bars v. So here we're going to use the square root, and we've been given the vector that its component forms are 6, negative 3. So this is going to be 6, 2 plus negative 3, 2. So we're going to go ahead and do the math. So 6 squared is 36, negative 3 squared is 9, so 36 and 9 gives you 45. Which we can simplify down to being 3 square roots of 5. Okay, so that is the magnitude. Now we're going to use that in order to find our unit vector. So your unit vector is going to be, again, the component where we are going to have v1, so 6, and we're going to divide that by the magnitude, 3 square roots of 5. And then we're going to do it again for the other. So we're going to have our v2, which was negative 3, and we're going to divide that by 3 square roots of 5. So with that, we have to just simply reduce the fraction, and so in this case we would get that our unit vector is 3 over the square root of 5, and then we're going to have negative 1 over the square root of 5. Now, for most situations, leaving the radical on the bottom in terms of vectors is usually okay. You want to pay very close attention to the directions you've been given to see if they're asking you to rationalize any denominators. However, in this case, I don't have any of that kind of direction, and so therefore this would be my component form, okay, which would be perfectly fine. Now, the other thing that we had to do is we had to use the linear combination. So we need to find the linear combination of my vector v. So that is going to say again that we have v1i, sorry, it's not a vector, plus v2j. And so in this case we just simply plug it in. This is going to be 6i plus a negative is going to be overridden by the negative 3j. And this would be what we were looking for. So these are my two answers that we were gunning for. Alright, so there you have it. Just a quick, fast example and explanation on unit vectors and the different things that you need to be able to do. Remember, your unit vector we use in order to find that linear combination. The linear combination uses the variables, or I and j, to represent your parallel vectors. So if you have any questions, or if you feel like you need a couple more examples, please let me know. Otherwise, I think I've rambled on enough. I hope you enjoyed yourself as much as I did, and I will see you next time.